Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at our third question from the 2018 Galois Math Contest. So, cylinder A has a radius 12 and a height of 25. Cylinder B has a radius 9 and a height 8. Just looking down at the pictures below, I feel like there was a question a long time ago from a Cayley or a Fermat paper very similar to this, which would just... and this is just from the picture stuff, I haven't finished reading the question, but just sort of goes to show you that reading previous contests, practicing previous contests, and looking at previous contest solutions can be beneficial, because sometimes questions come back around, they come in style again. Okay, so radius 9, height h. Now, I don't know what h is. One of these parts might ask me to find h. Who knows? Cylinder A is filled with water to a depth of 19. So, it looks like we've got some pictures of a process happening down here, but I imagine we probably start with cylinder A, and the water is up here to a height of 19. The total height is 25, and the radius down here is 12. Cylinder B is empty. Cylinder B is lowered into the bottom of A as shown. So, an intermediate step would be here. We're starting the lowering process. And then water is getting pushed out. Looks like it's getting pushed out over the sides. If the water level rises above 25 because the volume of cylinder B is displacing it, then water should be flowing out. Depending on the value of H, we have some possibilities. Some water may spill out of cylinder A onto the ground. That's figure 1. Some water might pour into the cylinder B, figure 2. Or it's possible that water will flow out, but then cylinder B will be lowered so much that its top, so that its bottom hasn't reached the bottom of cylinder A, but it's still below the water level, so water will start flowing into it. Okay, so some might flow out and then eventually flow in. So that's what we're looking at. Okay, so these are our possibilities. The walls and bases of the two cylinders are thin enough that their width can be ignored. Good, so we don't have to worry about that. We can just calculate some volumes and talk about the fluid. It is water, right? Yeah, water. Okay, so we've got 3 parts to this question, a light bulb and 2 writtens. The light bulb asks, suppose that H, the height of cylinder B, is 30. What is the volume of water that spills out of cylinder A onto the ground? Okay. So, when the process is all done, so I find for a question like this where we're talking about certain times where things are sort of happening, that it's sort of a good idea to understand what's going on in the process. So we might start with the water at 19. Well, let's use blue. So I feel like drawing a sort of a storyboard is going to be useful for this question. And at the start, B is slowly being lowered in. Now eventually it'll hit the water, and the water will start to go up around it. And then we'll reach some point where the water level now rises to the height 25 and is prepared to spill over. After that point, any more that we push cylinder B into into cylinder A will cause water to spill out. Now H here is 30, so the top of cylinder B will always be above the water level, and so water will never flow in, and that's an important thing to realize. So I might say water doesn't flow in. So we're just in scenario I, or 1. So we'd say that since H equals 30, which is greater than 25. Okay. So in order to figure out how much water actually flows out, what we should do is find this sort of key moment in time where the water level just gets high enough. And so that'll be when cylinder B is sort of B centimeters or whatever the unit is, B millimeters, deep into A. So at that point, that plus the volume of the water is it, what units? I don't think it is units. So lower B units of cylinder B plus volume of water equals volume of A. That's when A is filled to the brim, but nothing is going over. And it's important that we realize that that's a point we want, because then, as we push B into A, we're adding more of a volume of air into A, and that displaces some volume of water. How much? Well, how much air is being added after this point? After the first B units, the first B inches or centimeters gets pushed in, how much more? And that'll end up being 25 minus B. So that's the volume of air that displaces or pushes out the water. And those amounts will be equal. Okay, so using our storyboard, we can sort of realize a plan of attack here. We need to figure out what B is, and then use 25 minus B. But we can sort of understand, well, where are the volumes coming from. Now, this is going to be important for, I assume, the rest of the question. I haven't looked at the rest of it, but the volume of water at the start is, it's basically a cylinder of height 19 of water. Okay, so it's important to remember your volume formulas. Volume of a cylinder is pi r squared h. So in this case it'll be pi, what's the radius? It's sitting in cylinder A, so radius is 12, and the height is 19. And I guess we could grab our calculator and actually work this specific number out. I don't think it's going to be particularly relevant what the exact digits are, but okay, here we go. 2736 pi. So that's how much volume in, I don't know, I guess we'll say centimeters cubed, that there is for the water. Now, the volume of A is, so this is something else that is a fixed volume. It's pi 12 squared, but now a height of 25. And that's 3600 pi. Now the volume of B can change depending on on H. It's pi. I don't remember what the radius is. Was it 9? I think it was 9. Yeah, radius of 9. So it's 81h pi. Okay, and for this particular question, h is going to be 30, but that's okay. So we know that 3600 pi has got to be 2036 pi plus pi times 12 squared, or not 12 squared, 9 squared. There we go. 9 squared b, and we want to solve for b here. So we can divide by pi, subtract on both sides. 3600 minus 2736. We'll get 864 is equal to 9 squared b. So, well, that's 81b, I guess. So divide by 81. It's not a clean divide. It's going to be 32 over 3. Okay? So that amount, that length from the bottom of cylinder B can go in and no water goes over. And this is actually probably going to be a useful number. We might come back to it later because that's the amount that you need to drop in before water starts flowing out. Okay, if the height of B is less than 32 over 3, then water will only start flowing in, and it'll flow in whenever sort of the top of B goes below the height there, which might be one of the later questions. I don't know, but anything over 32 over 3, the water will start flowing out. It might eventually start flowing back in. We'll see, but in fact, it will. If it's between 32 over 3 and 25, the height of cylinder B, then you'll get flow out and flow in. But if it's over 25, you'll only ever get flow out. And if it's under 32 over 3, you will get flow in eventually, I think. Yeah, it should be. I don't know. That might be one of the later questions. We'll cross that bridge if we have to come to it. But 32 over 3. Okay, so any height of B beyond that is going to start giving us sort of a pocket of air inside B that represents volume of water being pushed out. Air is going in, trapped inside B, and so it pushes the water out the sides. Okay, so how much is left? Well, it'll take till the height of 25. So B will go in until it's sitting on the bottom. And so 32 over 3 has already been accounted for. That volume was fine. And then anything more up to that height of 25 should push out more air. So there we go. So what do we want? So volume above 32 over 3 and below 25 displaces an equal amount of water. So, and we just want the amount of water spilled out, right? What volume of water spills out? So this is going to be our final answer. We'll have pi times 9 squared, because it's the volume of air in B, but that is equal to the volume of water that's being pushed out, times 25 minus 32 over 3. I might end up using my calculator in a moment, but let's see what we can do. 9 times 5 is 45. 45 squared is 2025. And then 81 over 3 is 27. 27 times 32 is going to be 8 times 27 is 216 times another 4 is 864. And then, well, I can put the pi at the end, can't I? I'll get a 1 here. 202 minus 6 is 196, and then minus an 8 is 116. I'm a little shaky on that. I'll double check with my calculator. 2025 minus 864. Yep. 1161 pi. And so that's going to be the volume of water displaced. And that answers A. But you'll notice that on the way we started learning more. We wrote down some very key numbers and values. This B, I think, will probably come into play later on. So it's important that we write it down and justify what exactly it is. Okay, and that's what our pictures do for us. Okay, so now we've got B part. This one will actually require some written work, showing formulas, volume formulas, and that sort of stuff. Suppose that H is 20. Determine the volume of water that spills out of cylinder A onto the ground, and the depth of water in cylinder B when it's on the bottom. So what they're saying now is that water will spill out, but eventually the top of B will go below the water level, which will be up at 25 for quite some time as water's spilling out, and then it'll start to go in. Okay, so perhaps we should storyboard this and try and understand, okay, at this time it's doing this, this is sort of an important transition period, this is it filling up, this is what it looks like at the end of the whole process. Okay, I find it's really useful in order to help clarify my thoughts. Okay, so we might say we know from A that the volume of air above 32 over 3 in cylinder B will begin to displace water. Okay. So, what's going on here? Well, we've got our water, and it starts to be lowered in. It lowers, and then we sort of reach a point where it's all nice and equal. Push it in further, and water starts spilling out. And then we'll reach this moment where, oops, I'm on the erase tool. And then we'll reach this moment where B isn't at the bottom yet, but the top of B is now equal with the water. Water will stop spilling out and now start flowing in. Okay, and if you want to, you can label this out. So 32 over 3 of B is in. Water flows out. 20 of B is in. Water flows in. Okay, and then B on the bottom. Okay. So, I'd say the sort of the key things are to know, okay, how much water, so from this point on, the volume of water is conserved. No more water is flowing out, and that's an important thing to realize. So the amount of water is the same in all of these situations. So we might ask, okay, how much water is left here? How much water is left on the outsides here? The difference between those is going to give me the water in B. So, when 20 centimeters or units of B is inside A, water begins to flow in. So we'll say water will no longer flow out. So the volume of water is conserved. From then on. Okay. So how much water is left? Well, we start with 2736 pi. How much water flows out? It's going to be pi 9 squared and then 20 minus the 32 over 3 that we learned in part A. Okay. So now, well, we'll just grab our calculator. We've got them. Why not use them? So 81 times 20 minus 864. So we're looking at 1980 pi. I'll just do that calculation once more. 20 minus 32 over 3. Multiply by 81. And 2736. Okay, 1980. So we've got the water that flowed out. Okay, so this amount of water is what's left. When B rests on the bottom of A. Water will be at height 20 around B. So, volume of water in A but out of B is going to be, so we have the radius of A times the height of the water, but we have to minus the volume of B. Okay, because B is in the way. Okay, so this is just going to be 12 squared minus 9 squared, so that's 144 minus 81. So that's 63, so pi times 63 times 20, so that'll be 1260 pi. So the volume of water in B at the end is 1980, the amount of water that's still contained within A minus the water that's in A but not in B. So water in A, not in B. And so this gives us the water in B, which is also water that is technically in A, but we're being a bit more specific with it. So 720 pi, and that's going to be our answer to B part. Okay, so the storyboard helps us clarify our thoughts. We point out the water is conserved. That's a very useful thing. We use information we got in A part to figure out how much water is left after one of these, I guess I would call them sort of equilibrium points, where the water sort of stops what it's doing and changes its sort of flow direction or something like that. So we know how much water is left, then we figure out how much water isn't in B, but is still in A, difference of the two, and there we go. And we've explained, we've used words, we've denoted which volumes we're talking about, we've described each volume, so it should be easy to follow. Okay? And that's an important thing to keep in mind. You want what you're doing to be easy to follow by the markers. Yes, oftentimes they look for just key numbers, but when in doubt, they do read things, and if they can't follow, then you might not be earning the part marks that you should be getting, but you couldn't explain it well, so no one knows that you actually did the right thing. Okay, so it's important to be aware of that. Alright, C part, we'll wrap question 3 up. Determine the range of values of H so that when cylinder B is on the bottom of A, there is some water in cylinder B, but it is not full. Not full, okay. So, what could we do? We need to have water in B. So automatically any height above 25 and above is out. And that's probably something worth mentioning. So any H greater than or equal to 25 will not give water in B. Okay. So, since the lip or the top of B never reaches below the lip of A, and hence the water level. So let's say the maximum possible water level. Okay, well now we saw well, no, I was going to say we saw an A, but the 13/3 is about water flowing out. It has nothing to do with water necessarily flowing in. Now, we did see in this most recent question that 20 results in water flowing in B. Okay, so what does it look like if B is full? So if B is full, then B is full of water. There's going to be water all around B. And there could possibly even be water above B. So if H is less than or equal to 19, but of course it's possible that water flows out and this isn't the right thing. Okay. If H is less than or equal to 32 over 3, by A, water won't flow out. So, at the end, the water will still have, and we can even draw a picture of this. B is not big enough to do anything. It's going to, sitting at the bottom, well below the initial water level of 19, because no water has been displaced. So at the end of the water will still be at height 19. And since 32 over 3 is less than 19, B will be full. Okay, so the more interesting range of values is this. Water might flow out, and enough water might flow out that when water starts coming back into B, B doesn't fill up. That's the big challenge now. Okay, so we'll be guaranteed now that when we talk about it, water will flow out. And so there'll be this nice difference of how much water is left. At the end, what should be that water level's height, that sort of a thing. I feel like some more storyboards might be in order, but definitely something to think about. So now, consider H. So consider 32 over 3 less than H, less than 25. So water will flow out. And then eventually we'll get all of B is lined up, or the lip of B is lined up with the lip of A. Water will stop flowing out, start flowing in. And then we've got sort of two scenarios we could possibly have. The water level in B is going to be some height. We just need that height to be less than H. Okay, so this I think the same sort of reasoning will apply. So water out. At this point, water is conserved. There will be no change in the amount of water. So, and we could even name this, so 1, 2, 3, 4. Nice, that way I can refer to things like at 2, water will stay constant from now on. We might say water in A will stay constant from now on. This volume of water is, well, we've got the 2736 pi that we start off with, minus the pi 9 squared, the difference in the height, and this 32 over 3 amount. Okay. So that's how much water will be left. And I guess we just sort of get a nice little formula in terms of H. So 2736 pi minus 81 H pi plus, right, because it's minus minus, and then the 32 over 3 times 81, or 864 that we've had before. So plus 864 pi. And so this would simplify to 360 pi minus 81 H pi. So that's how much water is left at this point. Okay, this will be a number that is less than 2736, just because by assumption H is more than 32 over 3. Okay, so that's how much water is left out. Okay. So, if B is full at the end, then what do we have? We sort of have a picture like this, where B is just sort of resting. It's like if you put a smaller, I don't know, like a shot glass inside a larger mug or a drink or something like that. It just goes right to the bottom, and the water level doesn't really change a whole lot, unless the shot glass had something in it. But in our scenario, it's it's air. Okay, so then this sort of height of the water, then, I don't know, we'll call this N. The natural height of the water. I want to be specific here as to what I mean. N is greater than, so let me just finish off my thought, H. So N is, I'm specifically saying this is 3,600 minus 81H over pi divided by, well, let's define it a little simpler and then rearrange. Where N is given by 144, so 12 squared N pi is, if you just took this volume of water, there wasn't any glass B, and you just put that back in cylinder A, what would that water level be at? So N gives water level if there were no B. Okay, so that's what we've got. So the water level, maybe even say water level in A if there were no B. Okay, so we can actually work this N out in terms of H, I think, and get maybe an inequality. Okay, one thing you might want to point out about this is as B sinks into into A, the water level around B stays at least at the height of the lip of B from the bottom of A. Nowhere in the process do we have B down here, and somehow the water is being held back, sort of Moses style, above it, and nowhere do we have water somehow below the lip of B. The water will slowly rush in as we go. Okay? So both of these don't happen. Okay? So that, it's something worth justifying or writing down, I think. Anyway, so N is 3,600 pi minus 81 h pi over 144 pi. So the pi's will cancel out nice and neat. So we can get rid of those. The pi's haven't really come into the question at all. 144, 360, so that should be 25, I think. And then 81 over 144. Well, we can divide both of those by 9. You'll get 9 on top and then 16 on the bottom. So 9 over 16h. So that's our value of N. So we need H to be more than N. Right? Because if it's less, then you could just sink glass B or cylinder B into the water for H and it wouldn't make a difference. It'll just sink right to the bottom and we'll be all set. So we just sort of need to solve this inequality. H greater than 25 minus 9 over 16h. Pull out to the other side, you'll get 9 over 16 plus 16 over 16 is going to be 25 over 16h. That needs to be greater than 25. Divide by 25, multiply by 16 on both sides. H has to be greater than 16. Okay. So 16 less than H less than 25 gives water in B, but B is not full. And there we go. So it looks like 16 will be the point where we rest on the bottom and then the water level around us is at the same height and B is just full as well. So that would be 16, and of course 25 is something we sort of experimented a little bit with in A. I mean, we had 30 there, but that means we'll have some water in here. Well, actually, it'll stay full like this, and no water will fill in at all. And so between those two, the amount of water is starting to decrease. The amount of water that's left in B at the end goes from all the way full to nothing at all, so anything in that range does indeed work. I like the numbers for that one. The numbers worked out nice and neat there. And I think, yeah, that's it. So let's make sure, determine the range of values of H so that when cylinder B is on the bottom of A, there is some water in B, but it's not full. There we go, so we're all set. So up next will be the very last question, question number 4. So we'll flip the page for that right now. Thank you guys for watching. Feel free to leave a comment if you had a different way of doing the question. Feel free to like, just to show some support, or subscribe to stay up to date. You don't have to do any of that, but it is appreciated. And I will see you in the next question for question number 4. Until then, take care.